Learn how to build AI recommendation systems that work like a personal stylist. Handling complex user queries like I need something for a special occasion and others. Traditional systems and even advanced models struggle with these multi-layered requests, costing AI engineers months of workarounds. Today we'll show you the self-evolving multi-agent architecture that can actually handle these complex queries. Traditional interactive recommender systems rely on rule-based or template-driven approaches, which limit their flexibility when you throw complex user needs at them. Even LLM-powered systems struggle with complex intentions because they lack solid planning and generalization abilities, despite using methods like chain of thought or reflection. Complex user queries hit you with ambiguous stuff like I need something for a special occasion or bundled requests that need serious reasoning skills. And current systems just fall apart when users have unclear intents, multiple requirements, or need personalized recommendations across different product categories. Let's have an example. Imagine user wants to get some blouses for a gathering with friends. Now let's break it down. So this request has different complexity types. So the first one is the usage demand, basically scenario-based, which is she wants to get the blouses specifically for a gathering with friends. So gathering with friends is a scenario. Then there can be also a match demand. Imagine it has to pair with her sneakers. And some of these demands can be also ambiguous, even this one, because it's also unclear of the dress code for this gathering or the preferences she has. That's why each of these dimensions has to be mapped into something more specific. For example, usage demand, gathering with friends, can be mapped into specific product attributes that can be casual or comfortable. Then based on this, we can already infer pairing and identify relevant clothing categories and types, such as blouses, tops, or formal versus casual, etc. And also consider multiple scenarios, because a gathering with friends can be anything from a dinner party to an outdoor event. So you see how complex it gets. A simple question about blouses for a gathering with friends at the end implies different product attributes, different matching types, and multiple scenarios, and all simultaneously. That's where TAIRA comes in. It's a multi-agent system with three key components: manager agent for central planning, executor agents for specialized tasks, and a thing called thought pattern distillation I will talk about later. The manager agent breaks down complex user queries into subtasks and dynamically plans execution using hierarchical planning. Executor agents include the searcher agent for retrieving product attributes, item retriever agent for filtering and ranking, and task interpreter agent for translating subtasks. Thought pattern distillation, for simplicity TPD, captures reliable thought patterns from successful agent experiences as well as the failed ones that were corrected by experts, and direct human expert knowledge. TPD creates three-part thought patterns: description of a task for abstract task types, description of a solution for conceptual guidance, and the thought template for detailed execution instructions. The system uses hierarchical and phase planning with iterative plan refinement, integrating the new information as it becomes available. TAIRA dynamically replans subtasks based on intermediate results, unlike rigid approaches that crash when initial strategies don't work. The multi-agent system balances execution flexibility with planning rigor through coordinated agent collaboration and experiential learning. Let's see how TAIRA is actually built. Everything starts from the user query. The manager agent, based on the query and the profile of the user, finds relevant thought patterns from the database. After that, the manager agent creates the initial plan, and task interpreter agent translates plans into specific executor instructions. Then these instructions are sent to the searcher agent to find item attributes, or to the item retriever agent to find the actual recommendations based on these item attributes. And throughout the execution, the manager agent keeps the plan updated whenever it's needed. And at the end, the user gets the final recommendations. And of course, all the experiences from the successes or failures of the agent, as well as the corrections by expert humans, are being saved back into our thought patterns. TAIRA was evaluated on 3 Amazon datasets against classic ranking models, agent planning baselines, and state-of-the-art LLM-based recommenders. It outperformed all baseline methods across hit ratio, normalized discounting, cumulative gain, and success rate metrics, delivering 4 to 15% improvements, depending on the metric. Performance improvements really shined on complex queries, showing superior handling of ambiguous and multi-aspect requests. Thought pattern matching was the most critical component. Once it was removed, it caused major drops in success rates, because without being able to remember its previous experiences, the agent was not able to plan effectively. The self-evolving multi-agent architecture of TAIRA demonstrates that effective AI recommendation systems for complex queries should rely on proper hierarchical planning and thought pattern distillation. By combining manager agents for planning with specialized executors and learning from both successes and failures, it achieves significant performance gains over traditional approaches. The original TAIRA paper, linked below, includes complete implementation details covering all prompts and system architecture specifications, and provides everything needed to reproduce this AI recommendation system, from manager agent planning logic to thought pattern distillation mechanisms.